initiate a conversation with
And if I could ask people to mute their microphones, please. I think, Robert, we can hear you.
I'm here. I was just waiting until the sign died down. Sorry. Anyway, so I'm not sure how you'll manage like who initiates a question and how somebody raises their hand, but I presume you've worked that out before, so I'll just trust you to know what you're doing and follow your lead. It's great to talk to you all. I've figured I should just have a very short introductory outline. You probably know what questions you want to ask and what you want to talk about. We can just get into that. But let me just set the largest framing. I definitely believe that eventually there will be powerful AI, powerful software that will be much more powerful than we humans are today, collectively and even individually, if you can divide it out that way. I definitely believe that eventually growth rates will increase, although they eventually later have to slow down. There will be faster growth, and faster growth could come relatively suddenly in the sense of within less than a current doubling time of 15 years, we could be in a whole new regime of much faster growth. And that some sort of artificial intelligence is probably the most plausible explanation for a next faster growth mode that we might enter into. Artificial intelligence definitely has the potential to be different, not only in terms of its ability, but in terms of its preferences. We are somewhat flexible in our preferences with respect to culture, and culture has changed just over time, and we are now different people than our ancestors were in terms of our preferences, and that our preferences can be summarized in part as ancient human preferences that were evolved in humans long ago, say a million years ago, and then more recently culturally imprinted preferences that are somewhat the result of cultural selection over the last few thousand years. And recent events, of course, have created recent cultural values, and we should expect that our descendants will also differ from us in many ways, both because they will just be in a different world and they will have adapted to that, because there's just randomness and random change, random value drift, if you will. And it's an open question just how much they will have in common with us value-wise. And I understand that many people are very concerned about that and would like to not have our descendants have different values from us. I have this book on Age of M all about very human-like artificial intelligence and what that world would be like. That's not the only scenario. It's a scenario explored. And there are other scenarios of less human-like software. At the moment, I've been working on a project to try to imagine what the future after EMS would be and where human-like and non-human-like software would win. And I do think that human-like software has a long future and can win in many places. And I can talk about that if anybody wants. And I think non-human-like software will win in other places. I definitely think that eventually there'll be a concern that any one piece of AI could be out of control. I mean, we've always had to worry about all of our devices staying in our control. There's more of a concern in the long run for more powerful things being out of control. I'm relatively skeptical about the scenario where all of a sudden one thing gets way out of control, as opposed to a world where many, many things are slowly becoming harder to control. And so I tend to imagine a world where there are many roughly equally powered things. And as an economist, imagine a world where no one's in charge and no one's setting everything. There's more competition that produces the outcomes. And I think that it's just too early now to do much work on how to keep future things in control. I think you'll have to see roughly what their structures are like and what their roles are like, and what the incentives are like and what the key accountability metrics are, et cetera, before you have much of a hope to think of useful ways to keep things in control. But then, anyway, so that's roughly my overall set of attitudes and interests and things like that, and that's probably enough to get us started. And I'll let whoever's the moderator here decide who talks next.
Okay, thank you for your presentation. If people could write in the chat if they have any interesting questions, and then I will start out with the first question. So my first question was, back when I first read the AI Foom debate between you and Eliezer Yudkowsky, there seemed to be you were talking a bit beside each other, in that Eliezer Yudkowsky was claiming that a Foom was dangerous because it happened so quickly. An intelligence explosion was something that was so quick that we would not have much time to prepare. And you were arguing that was not so likely because it was that a very local Foom was unlikely. So that to me leaves open the question of a global Foom, in that an intelligence explosion that is rather broad but also very fast. Do you think that's likely?
I was trying to signal my beliefs on that when my initial comments, to say that I do think that rapid change is possible and even likely. So that my best guess next doubling time for our successful economy would be, say, monthly. Today we double roughly every 15 years, so that would be a much faster growth, and that could happen, any time in roughly the next century or two. Probably not in the next 2 decades, but possibly, that would be literally, if that's driven by artificial intelligence, that's faster growth driven by smarter machines. If that counts in your mind as a global Foom, fine. It seemed to me that a lot of the concerns were focused on the one machine that takes over the world in a weekend sort of thing, and that if that's not your scenario, you have different concerns and you want to do something different about it.
To clarify, until someone else has written another question, worry was about a Foom that took on the order of months to half a year or something like that, which is basically too fast for us for humans to do much other than pre-planned precautions.
Well, I would imagine whatever happened is the result of many organizations in the world having access to powerful machines, and then using those machines as they intended. And, if that took a year, there could still be, a decentralized scenario where no one of them has great influence. Then the question is, what is it about that scenario that worries you, is the key question. So in the Foom scenario, the local Foom scenario, the scenario is there's one machine that takes over the world in the weekend, and then it controls the world. It makes the world do what it wants. That was the presented scenario, and that its values would be pretty hard to predict from that context. That was the thing that would make you worry there. But in a world where many, many parts of the world are growing together fast, the question is, what exactly is your concern in that scenario?
I think I will return to that. In the meantime, Robert has a question.
Yeah, it feels like a slightly related question, and I admit that I have not read everything you've written about this, so I don't know if this is...
That would be hard.
Well, yeah, I've not read even a appreciable portion, probably a fraction. Anyway, so there's this mistake that I think people make, and I know that I used to make, of kind of imagining an AGI suddenly coming into existence in our world, or one that looks very much like our world. And I think your position, if I'm not mistaken, is that by the time we have AGI, the world will look fairly different, in that we will have all of these other AI systems which are almost AGI, or that are like not as powerful, but there will be a large number of like existing powerful systems in place already. And so this like Foom, where one thing suddenly gets a decisive strategic advantage over the entire world, becomes unlikely, and it's more likely to be like a multipolar scenario where the new system has to like take into account the values of all these other systems. But like I can see two different possibilities there. One of them is, that there's all of these existing like capable systems which could keep the new one in check. The other one is that like you might have kind of an overhang, where if you have a lot of narrow but very powerful systems, those could be co-opted or taken over or, hacked or whatever by a new system that just that's only really good at like hacking and psychology and strategy and that kind of thing. I'm wondering what seems more likely.
I would regard those other scenarios as other variations on local Foom. Maybe elaborating that category makes you think them more likely or more concerned, but the key difference is, does one thing grab control of everything? Or are there many sources of power and influence that are roughly comparable?
Right.
The default, the multipolar scenario, the default scenario that I tend to think is far more likely is that there are many systems in the world that grow in capability, but no one of them is vastly better than all the rest, nor does any one of them suddenly grab control of all the rest.
Right.
It doesn't grab the financial markets and win all the money. It doesn't grab all the military and have all the bombs. It doesn't grab all the computers and therefore, et cetera.
Right.
That people have always long been protecting their things from theft, and that there's no sudden Foom of theft to allow one thing to grab everything through whatever channel: theft, war, clever persuasion, interpretive dance.
Yeah. Okay. Yeah, because I'm just kind of thinking about it in the same way of overhang that people are talking about, like hardware overhang or.
So overhang would be when you would get one little thing that allows you to also get a whole bunch of other things. In essence, it's sort of a threshold effect. So threshold effects can certainly allow more variance in ability, but the question is just how much variance are we talking about here? I mean, we certainly see a lot of threshold effects where, say, any one company gets a new innovation and allows that company to beat its competitors out for a while. But we're talking about a threshold that allows one thing to take over the world. So that's a vastly larger threshold than we've ever seen.
Right.
And so this will give me just a chance to make my side comment. I mean, I decided to, instead of making a longer speech at the beginning, to have some other speeches ready when the topic came up. So one little speech that I have ready is just the story that innovation isn't continuous. It is lumpy, and therefore there could be big lumps. But we have a lot of data on the distribution of lumpiness of innovation. And at least by, say, academic citation of papers, that distribution is pretty constant across different academic areas. So it's actually a pretty robust distribution. And in the standard distribution, most of the weight in innovation is in many small lumps, but every once in a while there's a big lump. And a key question is, what's the chance of an enormous lump in this area? Obviously, a priori, the odds of that are pretty low if you think it's not different than all the other areas we've ever seen. So then the question is, well, what are the arguments for thinking that this area is unusually different in making us expect there to be a really big lump just at this point where the Foom sort of thing would happen? I guess, should we go to other questions? Or
Yes, I think Ashwin had a question following up on the global Foom idea.
Yeah, so I guess pretty similarly in this vein, I guess so like it seems a little bit unobvious to me that just because the level of resources is fairly similar across different groups, that therefore there's no decisive strategic advantage. There's this idea of offense-defense balance, for example, and of offense-defense scaling, which I don't know if you've seen from Alan Defoe. I'll link to the paper here, which basically argues that it's possible, depending on the technology and depending on the situation, for more resources coming in to either allow for a more decisive first strike or to allow for sort of defenses to better protect against a first strike. And it's not at all obvious to me that it's going to be the case in every area or most areas that resource investment due to AI will be defense scaling rather than offense scaling, if you want to frame it in those terms, allowing for prevention of getting your technology hacked or resources stolen or whatever, rather than the reverse. And so it seems possible that you could in fact have this kind of snowballing. And it doesn't seem that requires any particular sort of large lump necessarily, so much as just the ability to have a moderate advantage that you happen to be able to leverage in a really
I would call that a lump. If you happen to stumble into a regime where you get a scaling advantage, then you end up accumulating a lump. The question is, how often do such lumps appear? I think often in these discussions, there's two different styles of analysis. One is to look at historical data sets and ask how often is there something like this event, and another is to just look in the space of abstract mathematical models and say what fraction of the space of models looks like this. And usually the space of models has much larger fraction of very concerning scenarios than the space of actual data. Mm-hmm. So for example, if you look at economic growth models, abstractly mathematically, it's just as likely that more growth makes growth accelerate as it makes it decelerate. But almost always the way we see in the actual world, there's very rare to have accelerating growth scenarios that at least last over very large scopes, and extremely common to have decelerating growth scenarios.
Sure.
And similarly for this offense-defense thing, I mean, yes, in principle, you could have an offensive advantage that lets one thing take over the world, but we've had a lot of history of offense-defense, and that's almost never been true on the large scale.
Sure. But I guess a couple points in that. One is like, this is a slightly different point, but related, that like, it seems like resources are like pretty lumpy. Like if you look at, especially if you imagine like, I don't know, like it seems fairly obvious that if you have this kind of economic growth type effective AI, it's going to be like governments are very interested in applying it to like military type technology. And there in particular, it seems like maybe like nuclear weapons are a big concern. Like there's some evidence now that like improved like just like data analysis type stuff is providing a greater chance of like a decisive nuclear first strike. And it seems like that's like a particular like, way that this could happen, that you could have like a sort of ability of military dominance coming from like a relatively small advantage.
Obviously offensive advantages sometimes happen, and they have sometimes happen in history. And you could look at our history to find the things closest to that and the most concerning. And, first strike nuclear war might be the closest analog to that. But, to leap from that to say that, therefore, an AI will kill the world in a nuclear strike is, a big jump, right? It's itemizing the most extreme possibilities you can identify. But you should admit that you have searched for the most extreme example, and if you look at the rest of the distribution, it's much less extreme than that.
I mean, I guess, but like it's also true that like you are going to have people like trying to sample from like the extremes of like the most powerful they can get, right? Like,
but that's always been true. That's been true for
sure.
Thousands of years. So the distribution we see is the result of people sampling as best they can for the most extreme things, and rarely is offensive win on this scale.
Sure. Yeah, I don't monopolize too much, so I'll let other people jump in.
Okay, the next question is from Chris. Chris Cooper.
Oh, yes, hi. I think basically it's perhaps been answered already. So the picture I get from you is that you regard an AI where accelerated growth, Foom, happens globally or in lots of different areas as being potentially could be intrinsically safer because there are likely to be checks and balances between different centers of AI, basically. Is that it, in just the way that companies and cities and nations?
Well, I wanted to distinguish the kinds of concern you could have. So if your focus is on one machine taking over the world in a weekend, I'm much less concerned about that. But now I have another one of my standard speeches at this point, which is to say, there's another concern that I have to say is overwhelmingly likely to happen, and there's probably not much you can do about it, which is just the general fact that so far in history, each generation has had values that differ from its immediate ancestors, and that on the long run looks like a random walk in the sense that you can't predict it very well, and that it seems very hard to prevent that. So that I think your default expectation for the future should be that when values can change, they will to some degree, and that's roughly a random walk. And if you don't like where that random walk tends to go, which is everywhere, you don't like that default future. And that's a very hard thing to not have happen, I think. That's a default way the generic future would play out when it's decentralized, is that there'll be some degree of value plasticity and value change, and it would just follow this large random walk. And so if you think that's a problem, then I say you do have a problem. You have a really huge problem, a problem that seems almost overwhelming to me. I mean, in the sense that it seemed relatively little chance to avoid it.
Well, a couple of points about that. One is, it seemed to me, thinking about this in the past, it seems, yes, okay, of course, future generations will have different values from our own, and we might be horrified by them, just the same way our ancestors would be horrified by some of our values. And really all you can do is perhaps say, well, let's try and ensure that the next generation or two are going in a way that we can endorse. Because, and let's hope then that our grandchildren can just make sure that their grandchildren have values that they can endorse, and so on.
But that's what people have always been doing, and people have always been trying to make sure that children and grandchildren share their values. And the value drift we see is the result of, those efforts.
Yeah. So our problem is that is going to change really fast if technology and consequent cultural values.
Well, just my higher level comment is just anything that you're worried about over the long run happens faster when change is faster. So I think, the high level bit to know about the future is it will be a world of faster change than the past. And so any generic concern you have that would have taken 1,000 or 1,000,000 years in the past will encompass within less than 1,000 years in the near future. So that's just because change is speeding up.
Okay. Could I perhaps make just one other point, which is connected, and that is that you refer to generations trying to limit, control, and constrain later generations, and applied to intelligent agents in the future, you seem to be implying that our AI successors really have as much moral right to go their own way as we would say that our own children and grandchildren have a right to go their own way, and that therefore we shouldn't be worried about AIs being our successors. Did I read too much into what you said?
Well, I usually try very hard to avoid making moral claims.
Yeah.
So I usually try to say anything else I can closely related to a moral claim without actually making the moral claim, because I prefer to keep my analysis in the space of facts rather than making bold moral claims that I find that I can't support or anybody else can support. So I might more say, some people think that AI is more plastic in values than humans are. And some people think AI is likely to drift farther, faster away from our values than, say, M's or humans would. I'm not so sure of those things. I think we will, in fact, make AI a lot like us, especially when they take on the higher level roles that we usually take. And that will include giving them, on the surface at least, values that look a lot like our values. They will change and evolve in response to pressures, but then so will the values of our descendants. So I think there's less of a difference there than many people see. But of course, that's all separate from the moral value push. I do think if you imagine a world full of AI, and you imagine two different worlds full of AI, and they're almost the same, except one is full of empty zombies and the other is full of lively things with feelings, I much prefer the second world. And I don't like. I'm very put off by the scenario of making sure there are no moral problems by making a vast empty universe with only a few humans off in some corner, whose values matter. Anyway.
Yeah.
Okay, I think the next thing that was written in the chat was Ali, but it didn't seem like a question. So unless you mind, Ali, we'll go to Matthias. Matthias, we can't hear you. Matthias, your microphone might be muted. Hello, or is it my Skype? Oh, yeah. Okay. So Ali, could you have your question, please? Hello, Matthias.
Hi.
Yeah.
So you did raise the point that having a universe filled with lively creatures does seem better than just having a bunch of humans on a rock. And I agree broadly with you. I mean, maybe if we did wind up making a bunch of paperclip maximizers and there were trillions of them and they were happy, perhaps that's not such a bad thing. But what about, say, more negative value drifts? If we wound up creating some sort of scenario that was, say, substantially worse than the Malthusian state, surely that is something we should try and struggle against, even if we have small odds of doing that. Like creating a world where it's filled with unhappy creatures.
Is there a particular scenario that you think that would generate that, or is it merely the logical possibility of it that concerns you?
I think it is the possibility, yes, just because space is vast and so is time. So it seems like something like that will wind up happening. And that does scare me a lot. And I would want to try and see if something can be done about that or make it a little less likely. And hence working on, say, value alignment and how to make sure that things don't go completely insane seems like a worthwhile thing to do.
Well,
or do you think it's just completely impossible?
At the largest level, my overall attitude is to not think I or any of us have that big of an influence over the future. So first we're in a world today where no one's in charge, and our world wasn't the result of any committee meeting a while ago. And nobody voted for this world, and it just happened. And mostly the future is going to be happening in that same way. And so I don't expect I or any of us have that much power over where the future goes. So I think our first priority is just to opportunistically guess where is it likely to go, and then ask, given the most likely scenarios, where on the margin would we like to push it a bit? Because that's probably all we can do. So I don't at all think in terms of like, what's the space of all the possibilities and what are the worst possibility and how can I design a world that prevents the worst possibility? Because that just seems way beyond my or anyone's capability to control the universe that carefully. So I would much more interested in like particular scenarios by which you think things could go badly, and especially if they are plausible scenarios.
Well, arms races in particular.
We've had lots of arms races before, so is it a different kind of arms race than we've ever had that's a concern, or is it
more
just
like
the typical arms race in the past, the one worry about, or a different one?
Generating creatures specifically for violence.
Well, that's who we are. So you and I are creatures generated for violence. Right?
Sort of, but I feel like there's a distinction that can be made here. We have violence as part of us, yes, but surely a lot of us is just built around a sort of, I don't know if I call it stable, but some sort of social system where we don't just try and murder everyone or take as much resources as we can.
Well, of course, but that's the winning violent strategy, is to cooperate within one violent side to be the most effective in being violent against others. So that is, we are predators and we're social predators, and we're good at being social predators, which means we cooperate within our internal alliances against the outside. And that we should expect winning predators and soldiers or fighters in the future to share those features. That's the generic winning strategy. Every fight of everything against everything is a really stupid strategy, and it will always be a stupid strategy.
Okay, did that answer the question?
Sort of. I mean,
for all these questions, I think we can come back to them in the sense that like they're all open-ended questions that there's no way we can like answer all of it. But so it's up to you how long to spend on each one, and then we can cycle back if we got time. I'm happy.
I'm backing down.
Then let's hear what Matthias has come up with, if he has managed to fix his microphone. I can hear you extremely weakly.
Faintly.
Sorry, you need to turn it way up. Okay.
You should work. Is it better now?
Whoever said that is great.
Okay, it's great now.
Yes, it is. We can hear you.
Perfect. Okay. So it seems to me, at least from what I gather reading your blog posts, that you generally seem to be favor of a very progressive economic policy where you try to, maximize the amount of wealth a society can generate. However, you've also stated here that you very much believe that everything that was bound to happen is happening at an ever, increasingly fast rate. To me, this seems like a very dangerous combination, as I'd very much like a lot of time to think about issues such as artificial intelligence before having the issue actually arrive. It seems to me that, a bigger amount of wealth is not gonna advance the speed of which we can decide on these questions faster than the speed at which these questions will have to be decided upon. Do you not see this as a very big argument against a progressive economic policy?
Well, again, I see myself and everybody I talk to as pretty limited in our ability to change the world. What I mostly could convince somebody is to increase some local growth rate of some city or nation, perhaps, or some industry. I don't have much influence over the growth rate of the entire world. And if you're worried about, learning to prevent problems, the much easier thing would be to focus on the people working to prevent that problem and increasing their budget and effort rather than trying to slow down the world, because slowing down the world is just really hard, right? It's a huge world and you're really small. But if there's a small part of the world focused on a problem, you could make that part bigger.
Yes, okay, that seems very reasonable. That as a single actor, it's like unreasonable to expect to be able to fix the issue through that way, and a much efficient way, a much better way would be to try a different approach. Let's say you had a switch where you could simply on a global scale decide this. Would you press the switch?
To slow down the world?
Yeah.
I'm reluctant to. So first of all, I think actually a lot of the current energy and desire to want to analyze these things is premature. That is, I think the world has to get bigger and more knowledgeable before we're ready to do much of this problem solving that people are eager to do now. So in that sense, growing a little faster would just get us to the point where we could start to worry about the problems. But then at that point, you might be wanting to slow things down so that you could work on them faster. But at that point, I'm not sure how much you could slow them down.
Okay, so your argument would be that slowing economic progress down now would simply just, extend the amount of suffering we have to do by living now instead of the future. And we're not going to be able to significantly positively alter things such as artificial intelligence at the current society we live in now. Is that correct?
Because we just don't understand these problems well enough to do much about them. It's just not the time to be doing much about them. When it is time to do much about them, it'll be because you're near, and then that's the moment you might want to slow other things down. And if you could, maybe you should, but it'll be pretty hard at that point to slow them down because you'll be near, and there'll be all these different people out there who could pursue them.
Do you not feel like this is like somewhat admitting defeat towards, for example, the risk of artificial intelligence?
You mean, but you're saying because I wouldn't push the button to slow down the world?
Well, it's just that...
there is no button to slow down the world, right? You know that.
No, sure. In practical terms, I understand you. I'd very much like to write up a few of my thoughts before continuing the conversation, but I found it very enlightening. Thank you.
Sure.
Okay, then it seems to be me who's next in line. And my question is... in AI safety, there's an argument for, or in existential risks, basically, that the future is very, very large. You could imagine, I think Bostrom has calculated something like 10 to the 16th life years that is possible in the universe. And of course, people who focus on AI safety, they believe that this makes it very important. But I guess even if you consider only like 1 in a billion chance that you can do anything substantially prevent an existential catastrophe, then I guess you need to multiply 1 in a billion with 10 to the 16th or something? How do you do that in a principled way?
I mean, you only have a limited amount of time, yourself, and energy. So you mainly get to allocate your time and energy to different topics. You can't scale up yours by a factor of a billion. You just don't have that as a knob. That's not one of your options. So you can ask, where do you want to look in time and in topic to focus your energies? And the fact that the future will be very important is certainly a reason to do what you could about the future relative to other things you could do something about. And then when you're trying to help the future, you have another parameter, which is sort of the unlikeliness and drasticness of the scenario that you're focused on. So if you think there's only like doing little tiny things that hardly matter or preventing extinction, then of course you might say, well, sure, even if preventing extinction, I can't have much of a chance on it. Maybe that's still really important to do, which makes sense if those are the only two options. But I really think there's a vast range of other options for things you could do to think and help about the future. Honestly, the first order of business in thinking about the future is just have the foggiest idea what it looks like. We are still at very primitive stages of even outlining roughly what various futures could look like. And I think it's very hard to be very useful about preventing the worst possible scenarios when you don't even have much of an idea what the typical scenarios look like. I know that, as abstractly that seems like the priority, you should find the worst scenario, then focus on it. But there really is a vast space of possible worst scenarios, and you don't know how to judge which are more likely than which other ones until you know what the typical scenarios look like. That gives you much more information about knowing which worst scenarios are the more likely ones to focus on.
Okay. Ashwin had a question.
Well, I guess following up on that, I'm curious, like, what sorts of like signs you think we'll have. Like you mentioned, like at some point in the future, maybe it would make more sense to slow down once we like know enough to be able to do more. So like, what sorts of like things would you think would like help us understand this a lot better than we do now?
So the scenarios people are worried about are AIs that are very agent-like and have a very broad range of discretion. Today and for the foreseeable future, automation will have very narrow roles. Eric Drexler has written about this topic before, and I think he's right. But we start with automation in very narrow roles and slowly move it up to roles with more discretion. Similarly, if you're worried about like foreigners coming in and messing up with your society, you don't worry very much if they're janitors or dishwashers or things like that. If their actions are limited to those roles, because it's really hard for them to come in and screw up your society by being a bad janitor or a bad dishwasher. Maybe as they're a janitor, they get to sneak into a room or something, but that's because, again, they have more discretion. So again, in the future, the concern, if you're worried about AI being out of control and causing problems, you're worried about scenarios where they have a fair bit of discretion and they are able to choose, across a wide range of things, some of which are important and risky. But that's a long way away from where we are now, in the sense that AI at the moment has very limited roles. And even most people today can't do much to destroy society, because most of us on our jobs have very limited roles in our jobs. And that's how we all keep each other accountable, is through what job we do and what metrics we use to see who's doing how well. So you don't really need to start worrying until the AIs you're worried about are doing much higher level jobs than even most people are today. They are politicians, they are military commanders, they are investment venture capital investors. They have to have a big choice where then the big choice could go wrong. That's when you should even start to worry about it.
I guess people are already thinking about having like more autonomy and like military drones and stuff like that. It seems possible that like
more autonomy is still pretty limited autonomy.
Sure.
No drone out there is at risk of destroying the world.
Sure, for sure. But I mean, you can imagine that like even with like a relatively like low level of, you have some like basic reinforcement algorithm going on or whatever, it seems possible that you could have something where, it's designed to track and like do basic responses to perceived like border violations or something like that, and that ends up like escalating into a local war. That's obviously not on the same scale as existential risk necessarily, but it seems certainly possible that like a relatively simple system doing relatively simple tasks could still ultimately end up sort of feeding into pretty bad scenarios.
Well, I mean, that's just every soldier has that, right? I mean, that's just the risk embodied in any soldier. We already have.
Sure, but the risks from AI soldiers are more correlated, though, right? That's at least one thing.
I don't see that necessarily. No.
Well, assuming that they're all implemented like with the same or similar technology, at least within a given military.
Well, I mean, so for example, if you just distribute some machine to lots of soldiers and they all have the same software and then it all gets invaded by the same virus, then that's a correlated risk across devices, right? So that's just a standard problem we have with hardware. Is hardware has a lot of advantages in scale economy and production and the ability to transfer and thing, but it often has correlated risks in hardware. Often in warfare, you found a flaw in one tank, and that's a flaw in all the tanks, and now you get to destroy all their tanks for a while till they figure it out and fix their tanks, right?
Mm-hmm.
That's not a new problem. It's just that's the nature of hardware in warfare.
But another military example would be giving a lot of control of your entire military system, like your mutually assured destruction systems, handing those over to AI systems, and that would be the equivalent, I suppose, of having of an AI having a high status job rather than being a janitor. So
right, exactly. So sure, when you're thinking about putting AI in control of the entire military, that's the point you could start to worrying. Well, okay. But that's very different than having an AI janitor. You're not really worried about the AI janitor taking over the world and destroying it all by being a bad janitor. You're worried about dust being left in the wrong places, or,
Okay, yeah, sure.
Okay, Jeb also had a question about AI in warfare.
Yeah, thank you. Can you hear me?
Yes.
Okay. I work in AI at one of the big AI companies, and I often say that the concern that I'm most worried about has not so much to do with AI safety in the sense of superintelligence or AI Foom, but the looming economic incentive to take humans out of the loop. My company goes to great pains to say that AI is augmented intelligence and it's about augmenting decision making. But I think I also, by the way, work in the D.C. area, very close to George Mason, and I work with a lot of military folks. And I see times coming when there's going to be more and more AI-controlled battlefield robots. And at a certain point, it seems very likely to me that there will be a very strong incentive to take a human out of the loop when a firing control command can be made faster by an AI without a human in the loop. Yeah. And even though nobody in their right minds wants armed, lethal AI, completely in control of their own decisions on the battlefield, at a certain point, the incentives are probably going to be there to make that happen. Can you comment on that?
Makes sense. That is, as you know, of course, our introduction of automation in the military has been quite slow and gradual, right? We don't suddenly introduce a super soldier who does everything. We automate a particular thing. We add more faster automation capabilities in a particular kind of gun or a particular kind of missile, but et cetera. And yes. But then at some points you will have a capable enough automation and speed will be of a high enough premium that you will automate the task mainly because of speed. So that's a little different than the rest of the economy. Speed isn't usually quite such a premium, but in the military, speed is an enormous premium. And just be able to even make pretty dumb decisions really fast can be a win. And so, yes, they will put those in the loop, and that will usually win, and sometimes it'll go badly because the automation is fragile and not very robust. And so, yes, that's the main trade-off. There's a middle wide, space of scenarios where it's a win, and then there's the tail of the distribution where it's a loss. And you have to be tracking the tails, and the trails are often hard to see and hard to collect data on. And so you will often make the misjudgment of estimating the tails to be low, and they turned out to be higher than you thought.
Yeah, I think the thing that concerns me there is what happens in warfare. I mean, I read something interesting recently that said that I guess it was World War II when they were introducing jet technology willy-nilly and without the usual safety concerns that they would have outside of war. Something like 15,000 pilots died inside the continental U.S. during that time. Because of the unsafety and the unbelievably rapid development. I worry that...
well, that's what happens. I mean, in war, you've got high, yes, you'll kill a lot of people by going fast, but then you'll kill a lot of people by going slow, too. And, that's where you're stuck in wartime. Yep. And, so a lot of people will get killed as a result of the enemy using automation on you, and a lot of people on your side will get killed as a result of using automation sloppily and too fast. Yeah, that'll happen, and I don't really see much general to say about it. That's just been the nature of hardware and war for a long time.
Agreed. Yeah, I just think that the one scenario that does kind of concern me is one where, where we get into an AI arms race in warfare in time of war. That seems like the one potentially likely scenario that trips us off into completely uncontrollable AI. But
I think that's about the ability of AI to generalize. That is, we would have an AI arms race in business if we could. I'm less worried about an AI race in warfare because I just don't believe that even though it's warfare and you want your AIs to be better, that means you can make them better fast.
That's certainly true.
Similarly, in business, you might want your AIs to be better faster, but they just don't get better as fast as you want.
Yeah.
And they don't generalize as fast as you want, and that'll be true in warfare. You'll have a tank AI, and you want it to be a howitzer AI, and it just won't turn into a howitzer AI, damn it. It'll just stay the tank AI.
Yeah, absolutely. And just observing what we do within the company, I can see that there's a good handful of researchers that have little pet projects on the side working towards AGI, but all of the financial incentive is to spend our efforts on the narrow AIs. I don't think
those work.
Yeah, exactly. Those exist. The AGI is theoretical at this point.
Right. Exactly. And for a long time to come.
Very likely, though. I've seen some fairly plausible designs that could. And
I've seen plausible designs going back 50 years. People have been working on their plausible AGI designs for a long time. It's an old hobby.
Good point. Thank you.
Okay. Chris had a question about when we'll know when AI is imminent.
Yes, I'm just wondering if you have any picture in your mind of what it will be like. Will it be just like an accumulation of narrow AIs in all sorts of areas of life, and so when they will just sort of turn around and notice for the first time that that we've got something we would like to call AGI, or maybe we'll never say that. Maybe we'll do what we did with chess playing programs and things, and just say, okay, well, it's what we're doing is amazing, but now we've got it. I mean, nobody would call that intelligence.
So again, you're looking for a lumpy transition to more generality. That's in a sense when you're saying, how will we know when AGI is here or about to be here? But it need not be that lumpy. So if you look back over the last 70 years of computer science, we've definitely had a lot of advances, and some of them have been lumpy, but the vast majority have been pretty small lumps. Our abilities in computer science haven't actually jumped in big leaps very often. And that's as true of looking on one axis of ability as it is on looking on an axis of generality. It's really quite rare to have a big surprising leap in generality. So I think that's what you should expect for the future. You should just not expect this sudden moment when everything turns out to be vastly more general than it was a moment before. You should be seeing the rate at which things were getting more general, and you should be able to project that into the future, and that'll be a pretty good guide to how fast things will get how general.
Mm-hmm. I'm just thinking, I'm working with a collaborator. We're trying to do a children's book explaining AI safety. It just occurs to me that for a dramatic story, you need a lumpy story, not smooth transitions.
Yes, and that's been a problem because a lot of people's intuitions have been honed off of science fiction and dramatic stories, where there's the one big lumpy development that drives the story.
Yeah. I have a lot to answer for. Okay, thanks.
Okay, then my question would be, back in the original AI Foom debate, you made a number of comments, I believe some very bold predictions about the AGI project called CYC, CYC. I think that did not turn out. CYC didn't seem to be a strong way forward. Do you have any comments on that?
When the AI Foom debate was happening, Psych was already a very old project. So I can't have been making predictions about Psych at that point, because it was long past Psych was, I mean, I could be talking about Psych just as a system and the kinds of system it is compared to other systems, but I'm surprised you could find me as making a prediction about Psych at that point.
Maybe I will need to read it, but your overall point seemed to be that the kinds of AI projects that were built up with a lot of content were more likely to be successful compared to AGI projects that were tried to build on some kind of architectural great idea.
And that is another way of talking about lumpiness. That is how lumpy are architectural insights. If architectural insights are not very lumpy, then it's equivalent to there being lots of what I called content. If there's a single architecture that's really different from anything before and it makes an enormous difference, then that's a very lumpy innovation. It's an innovation in architecture. And so yet the key question is about the distribution of lumpiness in innovation in AI and computer science more generally. And so, I have a number of lines of argument there. One is just we have general data about lumpiness and innovation in general. We have lumpiness and innovation as represented by, say, citations of papers. We have lumpiness in the history of computer science, and even AI more specifically. And on all of these things, I think relatively consistently show that the vast majority of innovation is in relatively small lumps, and big lumps are relatively rare. And often big lumps get more credit than they deserve. So, for example, recent advances in deep learning, a lot of it can be attributed to a big increase in the amount of hardware devoted to using methods that we had for a while ago. And if you correct for the hardware, actually it's nearly on target for the kind of abilities you would have predicted.
I believe you had in the AI Foom debate you made some kind of outside view argument to show that you expected true AGI to be something like 100 years ago. Do you remember the argument you made?
100 years ago?
No, sorry, 100 years in the future, sorry.
One line of argument that I've given, although I'm not sure it was in the AI Foom debate, but it may have been at that time, was is just a survey that I've made of AI researchers.
Yes, that was
where I've met them and I've basically asked them, in your field of expertise, in the last 20 years, how far have we come? I think it's more reliable to ask people what they've seen in the past than make their guesses about the future. It's more reliable to ask them about this field they know best than to ask them about broad overall trends in very large fields that they don't know very much about. So the usual way of doing things is to ask people how much progress will they think the entire world will make in the next few decades. Whereas I think it was more reliable to ask an AI researcher in a particular field how far their field has come in the last 20 years. And the only interpretive part I asked them is to say, how far have we come as a fraction of the distance to human level abilities in your field? And then they have them give that to me as a percentage. In the last 20 years, how far have we come as a fraction of human, toward human level abilities in the last 20 years as a fraction? And the sort of the median answer I get is 5 to 10%. And then I have the follow-up question, any noticeable acceleration? Typically not. And then the obvious extrapolation from that is to say, well, then we're talking 2 to 4 centuries.
Okay. Jeff has a question.
Yes, actually, I was wondering if Dr. Hanson could tell us about, if you, Dr. Hanson, could tell us a bit about your work and whether you're doing any research work, projects, etc.
Well, like I indicated at the beginning, I have this grant from Open Philanthropy, and I've had it for a little over 2 years now. And the pitch was that I would analyze an AI scenario like I analyzed Age of M. And I basically said, let's assume that the patterns we've seen in software for the last 70 years are reliable indications of the future. So how will you predict the future of software if you were just to look at the past patterns of software and say that that would continue? And so I've been struggling, but coming up with some insights, I think, into what I can say about what the future world of software looks like. And since the time I started that, I've leaned more toward the question of, imagine that M's show up, but we also have non-M software. Which kind of software wins where? And what does the world look like after the non-M software gets really good? Are there any M's left that are competitive and can do jobs, more cost effectively than the other kind of software? And so I have a number of things I can say, I think, about what that world looks like. There's not nearly as many things as I can say about the Age of M, because I could say so many things about that because they were very human-like. But I have a number of things I can say I'm proud of figuring out. And then it would take, I don't know, 5 or 10 minutes here if you wanted me to walk through the things I think I can say.
I'd like that very much. I think you hinted a little earlier about areas where human-like intelligence is likely to be successful, and areas where non-human-like AI might be successful.
Right. So, but I will defer to the organizer here to decide how much time to spend on those sorts of things, because that would take me a little speechifying time.
We said that we had planned 1 hour, and the hour is almost up. But I'm very interested in hearing that. So, unless anyone objects, then I would like to hear some more.
Any objections?
Please go ahead.
Okay. So, the challenge is just to think of software as a general phenomena, and ask what general things can we say about it that we could use usefully to project into the future, and especially as by comparison with the software in our brains. One of the simplest things I can say is very simple. It's based on something called Conway's Law. Conway's Law says that when an organization has a structure and then it makes software that has a structure, the structure of the software tends to reflect the structure of the organization. There are 3 organizations that are working together to make software. Well, the software will have 3 modules, 1 for each organization. If you've ever worked in software, that sounds kind of obvious, but it has a dramatic implication. It says that in the future, as we replace, say, humans with software, we could end up with a world that looks a lot like our world in the larger scale structures, because the organizations that replace us with software will end up creating software that reflects their structure. So today we're in a world with structures like, jobs, tasks, jobs, divisions, firms, industries, cities, nations, etc. And if we slowly swap out people for software on each of these things, we could end up with a world that mostly has these things done by software, but still looks a lot like the world we live in at those larger scales. So that's just one interesting thing to notice about the inertia of software structure. A second thing to say is that today when we look at human jobs, we can see each job is composed of tasks, and we can ask for a task, what other tasks tend to be done in the same geographic area as that task? And those tasks tend to be jobs that are trying to coordinate with that tasks. So tasks tend to be co-located in space, and even co-located in firms when they are tasks that need to be coordinated more with each other. And if you look at that network has a center of the network where of the tasks that are highly coordinated with many other tasks. And those tasks actually tend to be done in city centers. And the most clumpy ones tend to be done in the biggest cities, and they also tend to be done higher in organizations. And we expect that as we automate tasks, we will automate the periphery of this network first. That is, if you have a task that has very few other interfaces, it's easier to automate that task because you only have to change a few interfaces. Whereas when you have a task that interfaces and has to coordinate with many tasks, when you automate that task, not only you have to change how you do that task, you have to change all the interfaces, or you have to coordinate with all the other tasks that it's coordinating with, and change how they deal with their tasks too. So that says that we will automate slowly from the outside in the sense of this network. So we will automate rural jobs before city center jobs, and we will automate jobs lower in organizational hierarchies before we automate jobs higher in organizational hierarchies. And the same principle can be thought of as, say, even inside of a brain or human. If you have a human doing a job, when you automate the job, you'll probably tend more to keep how that job interacts with other jobs the same and change the internals of that job. And you may even end up making, systems that look like humans, except you automate the insides different. So like if you think of a human brain as composed of 1,000 modules, you might less change how those modules interact with each other and more change the internals of each model. So the general principle is just when you have this network of things in some sort of hierarchical structure, you more often change the internals of a structure than the interfaces. And therefore, if this is a network, you're more changing the periphery of the network relative to the center. And so that says that, similar to what I said before, we'll spend a long time automating peripheral tasks that are relatively isolated, that don't have enormous impact. And the last things we would automate, if we automated them, would be the center of this network, which is the jobs that are most coordinated in the city centers, high levels of organizations today, like, marketing, management, law, things like that, governance. So that's the second thing to say. I think I can say somewhat robustly. And the third thing I have to say, which is the third and last thing I think, is that in order to ask where do human software win relative to other software, we need a simple model of what is the essential difference between the kind of software in our heads and the kind of software that we write. And my best guess for that essential difference is to say that the software in our brains did not separate out some things that we separate when we write software today. So the machines we write today on our own computers, we separate hardware and software, we separate learning and doing, we separate memory and processing. These are just standard things we separate, and we make them in different places, and we can swap things out, right? We can swap out a different memory of the same processing, etc. In the brain, these things were all mixed up. And in particular, hardware and software is mixed up. That is, you don't have a separate place you store software that you can swap into any particular hardware. And each place in the brain is both hardware and software. So this has a dramatic implication for the evolution of the software in our brain. It meant that when evolution was trying to change the software in our brain, it couldn't do what we do now when we write new software. So today, when we, a human, write new software, the obvious thing we do is we start with a blank screen, and we just start writing new software. And then we connect it to other software as we desire in terms of, we don't like to connect things because that makes things less modular. On the other hand, when other stuff already does a task, then that's better to connect it to something that already does it, then we don't have to rewrite that. And that's how we write software. But in our brain, when evolution was evolving our brain, it couldn't do that in the sense that it had a limited set of hardware, and it had a very difficult time adding more hardware, and all the hardware it had was already devoted to other tasks. So all it could really do was try to cram in a little more hardware, or delete some old hardware in order to replace it with new hardware, or find some way to reorganize the pre-existing hardware-software combinations in a better way that will allow a small addition to do the new task. And so evolution, having this strong hardware constraint, spent a long time searching in the space of reorganizations. It just couldn't rely on modularity so much, because it just couldn't add more software anytime it wanted, because that was tied to hardware. And so the human brain is just naturally much less modular and much better integrated. And so that right there has dramatic implications for where human software wins and where it loses compared to other software. So the other software we write, because we can make it modular much better because we can just start with a blank screen, we use modularity all over the place as a way to make stuff work and to avoid problems. Modularity is basically our strongest tool. And in using modularity, however, we don't search a long time for the very best structure. We find the first structure that occurs to us that's pretty good, and then we just go with it. And it turns out, of course, in the longer run, as we have to evolve a system and add more things and change it, the structure we chose wasn't that great, and this means the system slowly degrades in its ability to handle new changes. And so we have the common phenomena of software rot, by which software degrades as we make it more complicated and we try to change it to adapt to changing conditions. And it rots faster, I think, than the software in our heads, because in the software in our heads, evolution spent a really long time searching for really good combinations of things that work well together, that are robust structures that would accommodate a lot of new changes. And so this tells us that, say, the software that software writes will probably be even worse in this regard, software squared, if you will. And so that'll limit how much we have software writing software. And humans will be best suited for tasks when there's a whole bunch of things that need to be coordinated carefully together, where modularity can't solve the problem, and software that we write is much better suited to situations where modularity works better, where you can just have a bunch of separate parts work on separate pieces, and then staple them together, and it kind of works. And so this is also telling you that humans will last longest at the jobs that need where a lot of different things to be coordinated, in the center of the network of tasks, where lots of different tasks need to be coordinated together. And the software we write ourselves will, again, work much better on the periphery of that network, where modularity works much better, and rot isn't less of a problem, and you can just replace things after they rot and start all over again. And so again, we have this image of a world where there's a lot of software, but mostly human-like minds are doing the high-level, general, abstract tasks where there's a lot of different little things that have to be coordinated carefully together. So I've just been talking for a while. I must have somehow lost. I'm not sure if I said it well or correctly. If there's clarifying questions, please ask.
Okay, I have a question. If we try to make a mathematical model of this slow process of automating these tasks, where if you imagine that, let's say, just for the sake of it, that 50% of the tasks have precisely one interface, and those are the easiest ones to automate, so we automate those first. And then after all the easy tasks at the periphery of the network has been automated, then obviously there is a lot of extra resources, people who are no longer need to work at these tasks, and then there's a much greater incentive to automate the parts that have two interfaces, and then this effect could accelerate quite quickly.
Well, you want to automate them. The question is whether you can. Again, when we write software that relies heavily on modularity, it's just very hard to find a really good structure that doesn't rot fast, that can integrate a lot of things. And the human brain software is a software that rots much more slowly and integrates far more things. And that makes it just increasingly expensive to even try to automate these center of the network tasks. You can try, you will try, but you won't succeed for a long time. Yeah. They're just hard.
Yeah, my point was that the incentive to automate them grows enormously as we move towards the center of the network.
Well, I'm not sure if the relative incentive grows that much. I mean, a key point about the age of a book that key point about M's in the age of M, which is that once we have brain emulations, then hardware advances improve M's just as well as they improve artificial software, the software we write. From that point on, it's only architectural design improvements that give artificial software an advantage. That is, you have to search in the space of software you can write to make it better. So far, you see, in our world, it's just the fact that hardware is getting cheaper so fast that drives the increasing urge to automate things. Even if it takes a lot of hardware to do something, pretty soon hardware is cheaper and then you just do it. But once you have M's, that stops being true. The hardware trend no longer drives the change.
Thanks for taking the time and giving us those insights. It makes a lot of sense. just a quick follow-up, if you have time. Do you have any thoughts, or can you share any thoughts anyway, on where you see your research going in the future?
Well, I'm personally relatively opportunistic about asking which things are the most important and where I want to go with that. I think I will write some sort of book based on this work that I've just described, but I'll put it in a larger context that's probably more engaging. And so I'm, asking myself which context to choose for those things. And then beyond that, I'm somewhat older in my career, and I have lots of ideas from the past that I could go back and build on. So the more of an install base you have of old project ideas and old projects that you partially built, the more tempted you are to go back and finish those than to start new things.
Yes.
So that'll probably be I do a lot of.
Thanks very much.
Which means I'll be less surprising because I'll be more, going back to things I've already done and you can see.
Cool.
Can I ask a sort of fun question? You obviously were very deeply involved in the whole prediction market thing. I don't know. You might even have invented it, but I don't know. Yes, and I'm just wondering if you have any wagers, bets, or prediction market investments or whatever in the area of AI.
I just don't think we're about to see a huge. I think we're near the peak of the current boom, and we're going to have a bust again. We've had boom and bust cycles go a long way back. So this is the wrong time to buy. This is the time to sell.
I see. So,
well, that's the short run, of course. These boom and bust cycles happen roughly a period of 30 years. So 30 years from now, it's time to expect the next peak of the next boom.
And have you put any money on that?
Well, I'm not buying. There's not much I have to sell. I'm not buying into AI at the moment. When I'm in conversations like this, I say, think about the long run. Don't really worry about, are we there? Is this almost time? No, it's not. If this was almost time, you'd definitely seeing a lot of big differences now. We are definitely not right near the threshold. But the long run it remains there, and then this is a good time to talk about the long run as long as everybody's thinking about the topic now.
Okay, thanks.
Okay, Ashwin had a question.
No, I don't think so. I was just making a couple comments. But thanks a lot for doing this. This was very, very interesting.
I'm happy to talk to you guys again if you want. And I'm really surprised if you've done 135 of these meetings. So that's every week for 2 years or something, or 3 years?
Yeah, 2.5 years, yeah.
Okay, wow. You must have covered a lot of ground.
Yes, we have. Ali had a question, and I think that will be the last question for tonight.
Yes, so I just wanted to ask about the age of M. You sort of made a few simplifying assumptions, like assuming the society would be sort of stable. Are you going to follow up with that idea and try and see what the biggest what the biggest branches would be, the most likely places where things could diverge rapidly, the largest sources of uncertainty? Are you going to try and see if there's anything you can say about that?
Well, the two main drivers here. One is just that when I wrote Age of M, I just got really obsessed with it and focused on it. And then when I finished the book, I couldn't quite turn that off. And so I kept collecting a file of editions. And then that was put into my updated paperback version. And then even then, since then, I still keep thinking about it because it's in my head. But the direction I most often tend to go is people say they'd like their fiction in the future in the form of fiction. And, could I set up a fictional scenario that would make this more vivid for people? And so that's the direction I'm mostly gone when I think about Age of M things, is what sort of characters, what sort of plots, what sort of conflicts, etc. could I put in this world so that I could make this world more vivid for people. I've got the overall message from the world that this was an interesting exercise, but that it was unusually focused on one particular thing the world isn't that interested in, except for the fact they liked the fact that there was just an integrated thing about one scenario. So I'm not feeling enormous pulls and rewards from people who want to know more details about the Age of M. Most people I said say that was a lot more detail than they wanted to hear about any future scenario, and they're surprised and even impressed that I managed to put so much detail about it, and that's kind of a planting a flag showing that you could say a lot of detail. But still, most people said they didn't really want to know that much about it. So there's not much demand out there for more that I can perceive. Although, if there was a fictional scenario, I could imagine there being more demand for, a sequel to a fictional scenario, because people then like to hear about that. And in the process of elaborating a fictional scenario, you would, of course, elaborate some other aspects of it. You'd be thinking about it, but that's where it stands now.
The idea of doing fiction about it seems really interesting, but I would be worried that in the future people might forget about Age of M and remember the fiction, and then when people want to talk about it, they say, "Oh, like that sci-fi book, huh?"
Well, I would only be thinking about fictional books that, in fact, were faithful to the world of the Age of M, where it was a real story, but it was in that world. I wouldn't at all be interested in dramatically changing the world for the sake of the fiction. I'm not going to add magic and
people might take the ideas less seriously if they don't realize that it came from a serious work and not from a fiction work,
I'm much more worried that it will just forget the entire thing. So I think if there was a fictional scenario that was true to the world, that is, it was there were characters in conflict, but the world they were in conflict was, in fact, the Age of M world I described, I would think that was a big win from the point of view of getting people to take the scenario seriously.
Fair enough, but the world needs more books like the Age of M. I thought it was fantastic.
Well, you guys are all hopefully, invited to try your hand at such a thing. That would be the way that Age of M would be most validated, is if we're inspired to do things like it.
Okay, I think that was a nice note to end this conversation on. Thank you once again, Robin Hanson, for coming and answering our questions. It's been a great conversation.
It's great to meet you all. And feel free to friend me or whatever. I mean, I'm not sure I've actually seen the names of all the people in this meeting. I'm just standing at a blank Skype screen. So, and I see some funny, Skype names, but I'd be happy to know the actual regular name of all you people.
Cool.
Great, thank you. That's terrific, yes.
Thank you so much.
Oh, and before everybody leaves, next week's AI Safety Reading Group will be on Tuesday the 4th, where we will read the first half of Nick Bostrom's new paper, whose name escapes me at this moment.
Is it about the vulnerable world?
The vulnerable world.
Vulnerable world hypothesis.
Okay, so that should be all.
Take care.
Thanks.
Take care. Have a nice
Thanks,
weekend.
everybody. Goodbye.
Nice week.